Lesson 4.5 covers pivoting. The simplex method uses an operation known as pivoting. To pivot a matrix about a given element, which is called the pivot element, is to apply the elementary row operations so that the pivot element is a 1 and all other entries in that column, called the pivot column, are zeros. In the following examples, the pivot element is given inside the brackets, and we're going to complete the operation of pivoting for the following. So let's look at our first example. We're told that the pivot element is a 3. So to complete this pivot, we need to make that 3 become a 1 and make all the other elements, the 8 and the -4, become zeros. So I begin by making the 3 become a 1 by dividing row 1 by 3. If I divide row 1 by 3, I get 0, 1, 2, 1/3. Be sure to use a fraction and not a decimal. 0 and 4. This becomes my new row 1, and you bring down rows 2 and 3. Now I need to make the 8 become a 0 and make the -4 become a 0. To make the 8 become a 0, I'm going to say -8 times row 1 because row 1 contained my pivot element. And then I'm going to add that to row 2 because that's what I want to change. So -8 times row 1 gives me 0, -8, -16, -8/3, 0, and -32. Then add this to row 2, which is 0, 8, 5, 0, 1, 80. When I do this, 0 plus 0 is 0. The -8 plus 8 gives me the 0 that I wanted. -16 plus 5 is -11. -8/3 plus 0 is -8/3. 0 plus 1 is 1, and -32 plus 80 is 48. And this is going to be my new row 2. Now you can either recopy the table now and add that new row 2 in, or you can go ahead and change the -4 to a 0 and then change both of those at the same time. So next I want to look at making the -4 become a 0. So change its sign to a +4. I'm going to multiply that by row 1 because that's the row with my pivot element. And then I'm going to add that to row 3 because that's the row I want to change. So 4 times row 1 is 0, 4, 8, 4/3, 0, 16. If I add this to row 3, my new row 3 becomes a 1, a 0 that I wanted, the 4 plus the -4, and then a 7, 4/3, 0, and 16. Replace row 3 with this new row 3 and recopy rows 1 and 2. So now with my table, if you notice, the column labeled X sub 1 has the 1 that we wanted and the zeros. If you also notice, I haven't listed my basic variables yet. After you complete the pivot, after you get the 1 and the zeros, some of the basic variables will probably change. So after every pivot, you need to reevaluate what your basic variables are. The last basic variable should always be a P. And if we look under the P column, I still have 0, 0, 1. That should never change. Then if I look at my second column under X sub 1, it has the 1 and the 2 zeros. The 1 is in row 1, so my first basic variable is going to be an X sub 1. Then to find my second column with the 0 and the 1s, I have to go under S sub 2. The 1 under the S sub 2 column is in row 2, so my second basic variable is S sub 2. So just don't forget, after you pivot, you've got to change your basic variables. Well, let's look at the next example. My pivot element here is the 6 in row 2. I need to begin by making that a 1. So to complete this pivot, I'm going to make the 6 become a 1, and then the other entries in that row, the 2 and the negative 2, I'm going to make those become zeros. So I begin by making the 6 become a 1 by dividing row 2 by 6. As you divide, reduce your fractions. So 0 divided by 6 is 0. 2 divided by 6 is 2 over 6, which reduces to 1/3. 6 divided by 6 is 1. 0 divided by 6 is 0. 1 divided by 6 is 1/6. And 24 divided by 6 is 4. So that becomes my new row 2, and I just recopy rows 1 and 3. Now I need to take the 2 in row 1 and make it become a 0. So change its sign to a negative 2. I'm multiplying by the row that contains my pivot element, which is row 2. And then I add that to the row I want changed, which is row 1. So negative 2 times row 2 is 0, negative 2/3, negative 2, 0, the negative 2/6 would reduce to negative 1/3, and then negative 8. When I add row 1, I get a 0, a 13/3, a 0, 1, negative 1/3, and 2. And this is going to become my new row 1. So add your new row 1 and keep rows 2 and 3 the same. Then finally we want to change the last row. The negative 2 needs to be a 0. So change its sign to a positive 2. Multiply by row 2 because that contains my basic variable. And add this to row 3 because that's the row I want to change. So 2 times row 2 is 0, 2/3, 2, 0, 1/3, 8. Then when I add this to row 3, I get a 1, a negative 1/3, a 0, a 0, a 1/3, and an 8. So this becomes my new row 3. So as we can see, under x sub 2, I've got the 1 that I wanted and then the 2 zeros. So now that I've completed the pivot, I need to look for my basic variables. The last basic variable should always be a p, and it still is. Under x sub 2, row 2 has my 1, so the x sub 2 becomes my second basic variable. Then under S sub 1, I have an identity column. The 1 is in row 1, so S sub 1 becomes my first basic variable. Next, we want to look at how to find the pivot element ourselves. So there's several steps for finding the pivot element. First, you always find the pivot column. To find the pivot column, you look at the objective function row. That's the last row in your table. In that row, you find the smallest negative entry. Find the smallest negative number in that row, and that's going to determine our pivot column. Now to find the pivot row, there's a couple of steps you need to do. First, we're going to divide each entry in the right-hand side by the corresponding element in the pivot column. And then just as a note, we don't have to do this for row 3. We're only looking for the rows above the objective function. Well, the smallest non-negative quotient that results, it gives us our pivot row. And in the case of ties, use either entry. So once we've got the pivot row and the pivot column, the pivot element is just the element that's in both the pivot column and the pivot row. So let's look at a few examples. So I begin by finding my pivot column. Look at the very last row. I have a 1, a -1, a -2, and then zeros. You find the smallest negative number, which is -2. That's under x sub 2, so my pivot column becomes x sub 2. Now I need to find my pivot row. I take my right-hand side, the 10 and the 24, and I divide those by the numbers in my pivot column, which are 2 and 6. So 10 divided by 2 is 5. 24 divided by 6 is 4. I choose the smallest one as long as it's not negative. So my smallest ratio is a 4. So that means row 2 becomes my pivot row. Now you find the number that's in the pivot row and the pivot column, and that's my pivot element. So this time the 6 is going to be my pivot element. We're always going to label our pivot column with the column labels. You know, the P, X sub 1, X sub 2, S sub 1, or S sub 2. We're always going to label our pivot row with just the row number, either 1, 2, or 3. And then for the pivot element, you just give that number that's in the pivot row and the pivot column. So my pivot element this time was the 6. Well, let's look at the next example. First, begin by looking at the very last row. The smallest negative number is -4. So my pivot column is going to be x sub 1, since that -4 is in my x sub 1 column. Now I'm going to divide my right-hand side by the x sub 1 elements to find my pivot row. So 12 divided by 3 is 4. 80 divided by 8 is 10. You find the smallest quotient that's not negative. So this time it was the 4. So that means row 1 is my pivot row. So now for your pivot element, look for the number that's in the pivot row and the pivot column, and this time it's a 3. So 3 becomes my pivot element. If I was told to complete the pivot or complete the operation of pivoting, I would make that 3 become a 1 and make the 8 and the -4 become zeros. Now in the next example, I have a 1, a -3, and a -7 and zeros in my final row. The -7 is the smallest one. So that means my pivot column is x sub 2, since the -7 is in the x sub 2 column. Now I take the right-hand side and I divide it by the elements in the x sub 2 column. So 12 divided by -2 is -6. 80 divided by 1 is 80. You use the smallest number that's not negative. Since row 1 gave me a negative ratio, I'm not going to use row 1. So my pivot row is going to be row 2. Now for my pivot element, the number that's in row 2 and the x2 column is a 1. So my pivot element is 1. Now let's look at evaluating a final simplex table. When solving a maximum problem using the simplex method, you keep pivoting until the last row, which is the objective function equation, has no negative elements. So I want to look at these tables and determine if they are the final simplex table or not. And if it is the final table, we're going to give the final solutions. So when you're looking at a table to determine if it's the final table, look at the very last row, and that comes from the objective function. If there are no negative elements, it is the final table. So since our last row here contains no negative numbers, this is the final simplex table. Now in this example, our basic variables are labeled for us. I know my first basic variable is an x sub 2. If you look under your x sub 2 column, you have the 1 and the 2 zeros. And the 1 is in row 1, so that's why x sub 2 is my first basic variable. Well, if I go all the way over to the right-hand side, I know its value is a 4. My next basic variable is an s sub 2. Under s sub 2, I have the identity column, the 1 and the 2 zeros. The 1 is in row 2, so s sub 2 is my second basic variable. The p is always my last basic variable, and if I go all the way over, its value is a 15. Now, since x sub 1 was not a basic variable, it equals 0. Any values that are not basic variables are zeros. My x sub 2 we said was 4, and our p was 15. So those are our final solutions. When you're given the final solutions, we just want the x's and the p's. We don't care about the s's, the slack variables. Now look at the next example. If I look at my final row, I have 1, 9, 0, and negative 5. Since that final row contains a negative element, this is not the final simplex table. This table would require more pivoting to get to the final table. Now for the next examples, I want to complete the following if possible. First, we're going to find the pivot element, then we're going to complete the pivot for that column, and then we're going to state the final solutions for the table. So let's begin with our first example. I want to find the pivot element. I always find the pivot column first. So look at your last row for the negative numbers. I have a negative 6 and a negative 5. The smallest one is the negative 6. So my pivot column is my x1 column. Now I want to find my pivot row. To find your pivot row, you divide the right-hand side by the numbers in the pivot column. So in the first row, I have 30 divided by 10 is 3. And in the second row, I have 60 divided by 15 is 4. I picked the smallest non-negative quotient. So the smallest number that's not negative is the 3. So my pivot row is row 1. And then finally for my pivot element, that's the number that's in the pivot row and the pivot column, and that's the 10. So now that I've identified my pivot element of 10, I want to complete the pivot operation for that column. This just means I'm going to make the 10 become a 1 and make the 15 and the negative 6 become zeros. So first, I begin by making that 10 become a 1 by dividing row 1 by 10. If I divide row 1 by 10, I get 0, and then 10 divided by 10 is the one that I wanted. 1 divided by 10 is 1/10. 15 divided by 10, be sure to write this as a reduced fraction, so that's 3/2. Then 0 divided by 10 is 0, and 30 divided by 10 is 3. And then you recopy rows 2 and 3. Now that my pivot element is a 1, I need to make the 15 and the negative 6 become zeros. To make the 15 become a 0, I'm going to change its sign to a negative 15. I'm going to multiply that by row 1 because that contains my 1, my pivot element. and then I'm going to add that to row 2 because that's the row I want to change. Now I'm going to do that first, but I'm going to go ahead on this screen and we'll just list how we're going to make the -6 become a 0. First, change its sign to a +6. Then we're going to multiply by row 1 because that contains my 1. And then I'm going to add that to row 3 because that's the row I want to change. So you can perform these 2 steps in one step if you want to and then rewrite one table, or you can do them in separate steps. So let's begin with the -15 times row 1 plus row 2. Well, -15 times row 1 gives me a 0, a -15, a -3/2. Be sure to always reduce the fractions. A -45/2, a 0, and a -45. When I add this to row 2, 0 plus 0 is 0. -15 plus 15 gives me the 0 that I wanted. -3/2 plus 0 is -3/2. -45/2 plus 6 is -33/2. 0 plus 1 is 1, and -45 plus 60 is 15. This is going to become my new row 2. So if you rewrite the table at this point, rows 1 and 3 stay the same, and you replace row 2 with that new row 2. Now, if you wanted to leave row 3 blank because we're just about to change that, you could. To get our new row 3, we say 6 times row 1 plus row 3. Well, 6 times row 1 gives me a 0, a 6, a 3/5, 9, 0, and 18. When I add this to row 1, I get a 1, a 0, a 3/5, a 4, a 0, and a 33. And this is my new row 3. So now I replace row 3 with this new row 3, and I leave rows 1 and 2 the same. Since I've completed that pivot, I don't list my basic variables because they may change. Now that I look at my table, I know this is my final table because the last row has no negative values in it. So all I need to do are label my basic variables, and then I can get my final solutions. And remember, your basic variables will probably change after each pivot. So the last basic variable is always going to be a p. And if you look in the column for p, I have a 0, 0, and a 1. The 1 is in the last row, so that's why the p is my basic variable for the last row. My second identity column is under x sub 1. Under x sub 1, I have a 1, a 0, and a 0. The 1 is in row 1, so that means my row 1 basic variable is x sub 1. Then my last identity column is under s sub 2. Under s sub 2, I have a 0, a 1, and a 0. The 1 is in row 2, so my row 2 basic variable is s sub 2. Since we said this was our final table, I'm going to give the final solutions. My first basic variable is an x sub 1. So to find its value, go all the way to the right-hand side, and there's a 3. So x sub 1 equals 3. X sub 2 was not a basic variable, so the value for x sub 2 is 0. My last basic variable is a p, so go all the way to the right-hand side, and it equals 33. So I have x sub 1 is 3, x sub 2 is 0, and p equals 33. Those are my final solutions. Well, let's look at the next example. I have negative values in the last row, so I know this is not my final table. I need to pivot in order to get my final table. So begin by looking at those negative numbers. I have a -9 and a -2. My pivot column is the column with the smallest negative value, which is a -9. So my pivot column is going to be my X1 column. Now to find the pivot row, I divide the right-hand side values by the pivot column values. So in row 1, 8 divided by 4 is 2. And in row 2, 18 divided by -5 is just -18/5. I've been saying I want the smallest non-negative value. So since -18/5 is negative, it's not going to be a possibility for my pivot row. So the only positive value that I have is the 2, which is row 1. So row 1 is going to be my pivot row. Now the pivot element is the number that's in the pivot row and the pivot column, and this time it's the 4. So to complete this pivot, I need to make that 4 become a 1, and then make the -5 and the -9 become zeros. So we'll begin by making the 4 become a 1. To get a 1, I simply divide. So we're going to divide row 1 by 4. When we do this, we get 0, 1, 1/4, 1/4, 0, and 2. So this is our new row 1, and we simply rewrite rows 2 and 3. Now that my pivot element is a 1, I want to make all other elements in that column become zeros. So the -5 and the -9 need to be zeros. Well, let's just write out how we would do that. To get the -5 to become a 0, I change its sign to a +5. I'm going to multiply by row 1 because row 1 contains the 1 in that column. And then I'm going to add it to row 2 because that's the column I want to change. Then to make the -9 become a 0, I'm going to change its sign to a +9. Multiply by row 1 because that's the row that contains the 1. And then add it to row 3 because that's the row I want to change. So let's begin with the first operation to get our new row 2. So begin with 5 times row 1. If I multiply row 1 by 5, I get 0, 5, 5/4, 5/4, 0, and 10. I'm going to add this to row 2. Well, when I do this, 0 plus 0 is 0. 5 plus a -5 is the 0 that I wanted. 5/4 plus 0 is 5/4. 5/4 plus 6 is 29/4. 0 plus 1 is 1, and 10 plus 18 is 28. This becomes my new row 2. So replace row 2 with this new row 2, and then keep rows 1 and 3 the same. And as I've said before, since we're about to change row 3, if you want to leave row 3 out and then perform that operation and then fill in the new row 3, you can. If you leave row 3 out, be sure to not copy the basic variables because those will probably change after we complete the pivot. Now my row 3 is 9 times row 1 plus row 3. So 9 times row 1 gives me 0, 9, 9/4, 9/4, 0, and 18. I'm going to add this to row 3 to get my new row 3. So 0 plus 1 is 1. That 1 should not change. 9 plus a -9 is the 0 that I wanted. 9/4 plus 0 is 9/4. 9/4 minus 2 is 1/4. 0 plus 0 is 0. And 18 plus 25 is 43. So this becomes my new row 3. So when I fill in my new row 3, I notice that that last row has no negative numbers. So this is going to be my final table. I want to list my basic variables. The last basic variable is a p, and it should always be a p and it shouldn't change. Then my next identity column is under x sub 1. The 1 in that column is in row 1, so my row 1 basic variable is an x sub 1. The final identity column is under S sub 2. The 1 in that column is in row 2, so my second or my row 2 basic variable is S sub 2. So now to list my final solutions, x sub 1 is a basic variable, so go all the way over to the right hand side and there's a 2, so x sub 1 equals 2. X sub 2 is not a basic variable, so it equals 0. P is a basic variable, so go to the right hand side to get the 43, so P equals 43. So my solutions are x sub 1 is 2, x sub 2 is 0, and P equals 43. Now let's look at an example of the case of no solution. Let's find the pivot element for the following table. I always begin with my pivot column. The only negative value I have in the last row is the negative 4. That's in the x sub 2 column, so my pivot column is x sub 2. Now to find my pivot row, I divide the right-hand side by my x sub 2 values. So 10 divided by negative 1 is negative 10. 40 divided by negative 5 is negative 8. We normally choose the smallest non-negative value, but this time we don't have a number that's not negative, so we can't complete the pivot. When this happens, the system is said to be unbounded and it has no solution. To help us understand this, let's look at a graph. So if I had the graph, I would end up having parallel lines. If both of my values, x sub 1 and x sub 2, are greater than 0, then that means I don't have any negative x values, which would be my x sub 1, and I don't have any negative x sub 2 values, which is, think of those as your y values. So I'm using just quadrant 1. Well, I want my maximum. Remember, we were maximizing the p function. So as you can see from this graph, the system would have no upper bound. So I am bounded below because my variables cannot be negative. But if you look at the upper right-hand corner of your graph, that continues on forever. There is no highest value. There's no upper bound. So because of this, the problem has no maximum. Whenever this happens, the answer to the original maximization problem is no solution. Don't tell me no upper bound. Don't tell me not possible. Tell me no solution, because the problem has no solution. Now let's look at our final example. In my last row, I've got 2 negative values, so I know this is not my final table. I have a negative 9 and a negative 5. You look for the smallest negative value for your pivot column. So this time my pivot column is with the negative 9, so my pivot column is x sub 1. Now to find the pivot row, I divide the right-hand side by the pivot column elements. So 8 divided by negative 4 is negative 2. 18 divided by negative 5 is negative 18/5. My pivot row is the row that has the smallest non-negative quotient. Well, if you notice, both of these quotients were negative, so I don't have a non-negative quotient. When this happens, that means the problem has no solution. So since I can't find a pivot element, this example has no solution.